Okay, for question E, the first differentiation assignment, we've got a function f of x, which is a whole lot of piecewise, well, it's a piecewise function with parabolas and straight lines and so on. We have to find out when the function is greater than 0. So it's basically we're looking at everything above the x-axis, everything up there. So when is the function positive and the derivative is greater than 0? So looking at this part here where the function is positive, the gradient of any tangent along there is negative, it's going downwards, so we don't want any of this. It's positive here, but the gradient will be 0. Here the gradient's negative, even though the function's positive. Here the function is positive, and my gradient is positive as well. And so we need to have an x is greater than 3 here. Okay, when is the function not continuous? That means you put your pen on the paper and you can follow the function down. It's continuous all here, it's continuous, continuous and continuous until we stop here. We've got to take the pen off the paper and then start up here. So we're discontinuous at -1, when x is -1. So if I started here, see if it's discontinuous anywhere else. I can keep my pen on the page all the way here. Keep it on the page. I've got to take it off here and then put it back down. So this open circle here means that there's no value when x is 1. And so I need to have 1 in here as well. Everywhere else I can keep my pen on the page and go the whole way. Okay, when is the function continuous and not differentiable? So I can keep my pen on the page, but I can't differentiate. So here I keep my pen on the page, it's continuous. I can differentiate all the way here. I can differentiate all the way here. It's not continuous. I'm not interested in that. Keep going. Here it is continuous. I keep my pen on the page, but it's not differentiable because I can't find a tangent at this point when x is 0. The tangent could be anywhere, because it's not a smooth part of the curve. At any corner, you can't differentiate. So x is equal to 0 anywhere else. Keep going. Not continuous there, so we're ignoring that. Keep going. At this point here, it's continuous, but I can't differentiate because it's a point or a corner. So when x is 2, I can't differentiate here either. When is my second derivative less than 0? So here, it would be helpful to draw a gradient function. So a quick sketch, that's my function here that you've seen. And then this is the derivative of that. So here the gradient's negative, which is why my gradient function is below 0. It's negative until here. This is where it's 0. So the gradient's 0. And then the gradient becomes positive. So I'm going above the x-axis. I can't differentiate here where it's discontinuous. I'm just putting open circles. Gradient's 0, so 0. Gradient's negative. It's a constant negative, which is why I'm constantly negative. Constant negative, constant negative. And the gradient is very positive, getting less positive. So it's very positive, doesn't matter what this value is. Very positive, it's getting less positive. It never actually gets to 0 that we can tell, so I'm just keeping it going here. Now the derivative of that, to get your second derivative function, ends up being something like this. And so we have here, the gradient was positive, so it stays positive, and it was constant. And then it was 0, 0, and then here the gradient was negative, very negative, and it got less negative, so we're kind of coming up towards 0. The question asked us, when's the second derivative less than 0? So less than 0 is this part here. Okay, so looking back at our graph here, that was when we were from 2 onwards, and so x is greater than 2. Okay, last part of that asks us for the function above, find the values of A where the limit does not exist. So for limits, you're coming towards a point from the left and the right. There's a limit all the way over here, wherever I come to. It's coming to the same place, but here, if I'm coming towards -1, from the left I go towards here, but from the right I go towards there. My fingers are missing each other. Okay, they're not coming to the same place. My left is going towards 0, my right is going towards 2. So there's, at -1, the limit doesn't exist. So when A is -1, and that's all, because in all the other points, say if we took this point here, come at this point from the left, come at this point from the right, I'm still going towards the same thing. My fingers are meeting each other. This point here, coming from the left, coming from the right, my fingers meet. This point here, coming from the left, coming from the right, my fingers meet. So there is a limit for everything else, except for here, at -1, where fingers are going to different places.